Welcome back. Now let's look at the final paper of the October-November 2023 series. Right, this is paper 23, and as always, since the mark scheme has been released already, then as well as watching this video, I will also recommend checking the mark scheme. And of course, if the video is too slow, then I'd recommend watching at 1.25 or 1.5 times the speed. Okay, it says refer to the insert for the list of pseudocode functions and operators. Right, number one, a program is being developed in pseudocode before being converted into a programming language. The following table shows 4 valid pseudocode assignment statements. Complete the table by giving the data type that should be used to declare the variable, the variable underlined in each assignment statement. Right, so first then, well, if we've got a division, I think a division we're always going to want to use real. Right, then the next one, well, this is just going to be a date. And I mean, notice here how the date, I mean, I think they do let us do it inside strings, well, I guess, yeah, inside quotes. But yeah, we actually don't need those quotes. Right, the next one, I mean, some people might think, well, they see the division, but of course, I mean, this is inside quotes, okay, so it's going to be a string. And then the next one, well, if we have any logical operator, so and, or not, right, that, well, I mean, yeah, that's then going to be a boolean. Right, other variables in the program have example values as shown, so active is true, fraction is 0.2, and code, well, this. Right, so expression. Well, again, well, we want to complete the table by evaluating each expression using the example values. Right, so fraction is greater than or equal to 0.2. Well, I'm just going to write true because, yeah, that part is true. Right, then if we go well, and not active. So if we say well, active is true, right, therefore not active is false. So here, if we have well, true and false, okay, that's going to be false. Right, the next one, so I mean, obviously, yeah, sort of using the correct order, right, with the brackets. We're doing what, fraction times 100, so that gives us what, 20. And I suppose we can say 20.0. Right, then plus 13.3, well, that's 33.3. Right, then if we just do int, well, int is just going to remove the decimal part, so that'll get us 33. Right, because again, we have what, 33.3. Then yeah, int will just remove the decimal part. Okay, right, then we get what, mid of code, and we start at character 4, then we get 2 characters. So character 4, well, that's going to be 2. Right, then we get 2 characters, so well, 2, 3. Right, then what we do, well, we do string to num. Okay, so this, well, obviously what happens then is this string 23. Right, I mean, that's going to go to the, let's say the integer 23. Right, then we just do what, 23 plus 5. Right, that'll be 28. And the next one, right, the length, well, true, and then concatenated with code. Right, so I guess well, if we think we're going to have this then, in fact, hang on, right, yeah, not code, right, it's going to be true. Right, so, yeah, I mean, well, let's count how many characters. Of course, well, true is going to be 4, right, then 5, 6, right, 7, 8, 9, 10, yeah, I think 11. Yeah, is that correct? Hang on, let me count again. Yeah, so I think 3, all right, 4, and then 4, yeah, okay, so that should be 11. Right, the programmer, okay, well, the program makes use of complex statistical functions. The required functions are not built into the programming language and are too complicated for the program to write. One solution would be to employ another programmer who has experience of writing these functions, as there is no time to train the existing programmer. Right, state one other way that these functions may be provided for inclusion in the program. So I suppose what this would just be, I mean, well, let's say use a library, right, or yeah, import a library. So yeah, let's say maybe importing libraries, or yeah, maybe importing a library, right, that already has these functions pre-written. Yeah, let's say that has these functions already written. Right, the next one, the hardware that runs the program is changed and the program needs to be modified so that it works with the new hardware. Identify the type of maintenance that this represents and give one other reason why this type of maintenance may be needed. Right, so if we're talking about, well, changing the program, I guess well, either because of, yeah, let's say some hardware requirement, right, or maybe because the specification changes. Right, well then that's going to be adaptive maintenance. So yeah, I mean, I think, well, of course we can just say adaptive, but I am just going to write maintenance as well. And yeah, how do we spell maintenance? Yeah, T-E-N. Okay, like this. And well, I mean, if yeah, hang right. If we just quickly think, right, what's the other types? So we've got corrective maintenance. So of course corrective, well, this is about correcting a program that doesn't work, right? So if there's a bug, okay, you're just fixing the bug, right? That's going to be corrective. Then there's going to be perfective. And perfective, well, I mean, this will be a program that currently works, but I mean, here we just want to improve it. And I mean, we're not talking about improving it in terms of adding more features, right? Because, well, I mean, let's say adding more features would be adaptive, but we're talking about we're talking about improving in terms of well, let's say like memory usage. Okay, so using less memory. Also, of course, speed, right? Just making it faster. All right. So anyway, well, let's think then. What's another time we could use adaptive maintenance? And I think that this can be, I don't know, maybe say adding new features. Yeah, let's say maybe adding, right, or modifying existing features. Right, yeah, adding or modifying existing features. And let's say because program requirement changes. Yeah, okay, let's say, yeah, because the requirements have changed. Yeah, or you could say what the program requirements have changed. Two, data is a 1D array of integers containing 30 elements. All element values are unique. An algorithm will output the index of the element with the smallest value. And we want to draw a program flowchart to represent the algorithm. Okay, so well, let's think then about the variables we'll need. I guess one will be index. And I think we'll also need the smallest value. And I suppose, well, I mean, yeah, okay, so this can be the index of the for loop, right? But then we're also going to have another one. Let's say what for, I mean, let's say what the min index, right? So the index of the smallest element. Because of course, well, what we want to do is we want to see what if the current, yeah, okay, well, let's say, right, if the number at the current index is smaller than the, well, let's say what, than the sort of current minimum. Yeah, or we could just say what's smaller than the element at the minimum index, because, well, I mean, yeah, like these two are going to be the same. Then, of course, we're going to update it and we're going to assign this current element to be the new minimum. So, well, let's think then about what we want to, well, yeah, okay, I mean, let's just declare these here or set these here. So I think for index, well, I mean, since we're using pseudocode, right, let's start that as 1. Yes, let's go set index, right, to 1. I think the minimum element, I mean, we don't really want to set the minimum to 0, for example. You know, likewise, we also don't really want to set it to 999 because you could have a situation where, let's say, all of the numbers are actually bigger than 999, right? Therefore, well, therefore, you know, when we get to the end of the program, it will say that 999 is the minimum, even though that didn't actually exist, you know, in our array. So I think what we can do, well, we can just set this to the, yeah, okay, right. So, well, let's set the minimum to be the first element in data. So, right, let's go set. Yeah, this will be, yeah, well, yeah, okay. So let's just go min, and that's going to be what, to data, and then yeah, let's just go what, index 1, like that. And I mean, maybe we can also have this minimum index. Yeah, although I think, I mean, really, we don't really need the minimum index because, yeah, okay, hang on. All right, so we do need the minimum index. Right, I suppose, yeah, we actually don't need, you know, to store this smallest value technically, because, I mean, what we can do, well, we can just do data, and then we just do, let's say what, I know, min index. You know, that can be how we can actually get the smallest value. But yeah, I don't know. I mean, I think let's have the smallest value as another variable anyway. So let's go what, min value. Okay, hang on, right. Okay, yeah, I'm getting confused here. So this min, right, this is the minimum value. So let's go, right, min index. And, well, let's just go to 1. Because, I mean, yeah, currently we're just assuming that it's the first element is the smallest. Right, and yeah, I'm just going to expand that box out. Then I guess we want to think, well, we just want to loop 30 times. And inside that loop, we're just going to check that, well, if the current element is smaller, right, than the sort of current smallest element. So yeah, let's just do that here. We'll just have this if statement, or yeah, is statement. Right, let's go is, and this will be what, data. So to get the current element, that's going to be what, data, and then index. And let's see, what is that? What's smaller than? and yeah, let's see if that's smaller than the what min value. So I think, well, the min value is just right, this min. Right then, if it is, so yeah, let's go here. Right, if it is, well, then what we want to do, we just want to set this min, and also the min index, yeah, sort of to this, yeah, sort of to these values. So let's try and do that then. And yeah, here let's just write yes. Right here, okay, let's write no. So what we want to do, well, let's go set, and this would be what, min index. So we're going to set the min index, well, to index. And we also then want to set what the min value, so that's going to be min. And then what, well, so the current value, that's, yeah, data, and then the index is index. Yeah, I'm going to expand that out again. Okay, right, so once we've done that, I mean, I think, well, let's just, yeah, we can probably sort of connect these back up. Alright, and then I'm actually just going to connect this back here. And I guess now what we want to do, well, we just want to increment the index, right, going to the next element. So yeah, let's go, what, set index, right, to index plus 1. Okay, and then, yeah, I guess now that we've done that, so I suppose here is where we just want to check, well, have we looped through all 30 elements? So what we would want to say is, well, we would want to say if index is greater than 30. Yeah, or, well, okay, or I suppose we can say, well, if index is less than or equal to 30, then we're going to loop back. Of course, yeah, well, greater than 30, that's going to be the ending condition. Right, so let's go is, and we'll just go index. Right, so is index, what, let's say less than or equal to 30. And let's go here, well, this will be the yes. And yeah, okay, so well, here then we're just going back to this one. Right, so let's just write yes. And then, well, no, and then what we just output. Yes, output the index. Right, so output then, that's going to be, yeah, this, you know, parallelogram. And I'm just going to give a message as well, so let's just go output. And what we'd say, maybe like, I don't know, maybe like smallest index, or yeah, element. Okay, all right, let's say so maybe smallest element, right, at index. Okay, right, so smallest element, yeah, at index. And then here, well, let's just write the, what, yeah, I think min, right, that's what we called it, or min index. And again, yeah, let's just expand that out. Okay, yeah, so I think, yeah, okay, right, so I think that should be correct. Right, then it says the 30 data values could have been stored in separate variables rather than an array. Explain the benefits of using an array when designing a solution to part A. So of course, well, you know, when they're saying separate variables, they're talking, I don't know, let's say like what, n1, right, n2, yeah, n3, of course, yeah, up until, you know, n30. But of course, well, the problem with that, I mean, basically, well, yeah, there's going to be no way we can loop through that. So that's going to be one benefit. Let's say, yeah, I mean, let's also say, right, it's going to be easier to understand. All right, so let's say, yeah, easier to understand. Right, since there's less code. Oh, yeah, okay, yeah, since there's less code. Of course, right, that's using an array, there's going to be less code. You know, having like all these individual variables, well, here there's going to be more code. Right, so easier to understand, right, since there's less code. And I guess we can say, well, and an array allows us to easily loop through all elements. Yeah, okay, let's say it allows us, yeah, allows us to easily loop through all elements. And I think we can maybe just expand that array, let's say, yeah, by using an index. Because, I mean, if you just say loop through, like, maybe they won't give you the mark. Yeah, maybe you also need to say, right, by using an index. Because I think, I mean, Cambridge, I mean, they're quite specific in terms of, you know, the keywords that they, yeah, have bolded, that, of course, they require. Right, the next one, the requirement changes. Array data needs to hold 120 elements. And each value may include a decimal place. right, we should write a pseudocode statement to declare the modified array. So of course, well here that's the dimensions, and well, decimal place, that's going to be real. So right, let's just go declare then. I think what we said is called data. Right, and then here, well, let's go array. And then after this, well, then we have the brackets, okay, and we just say the dimensions. Right, here it's going to be, well, 1 to 120. Right, then we say of, and yeah, let's just go real. Right, so the data type. And yeah, I mean, sometimes I see people doing, different syntax for array declaration. But if you actually look at the mark scheme, they only give you this answer. So I would say, make sure to actually kind of learn the syntax that Cambridge use. Okay, then 3, the diagram represents a queue abstract data type. The organization of this queue may be summarized as follows. The front of queue pointer points to the next data item, to be removed. The end of queue pointer points to the last data item added. Okay, so here we can just see this, then the front of queue pointer points to D3, right, end of queue pointer points to D5. The queue is implemented using 3 variables and a 1D array of 8 elements as shown. The variable num item stores the number of items in the queue. Right, the pointer variables store indices, right, index numbers of the array. Complete the diagram to represent the state of the queue as shown above. So yeah, I mean, I think this one is similar to question, okay, let's say paper 21, I think it was. I mean, so first then, well, we just want to copy these values, right, the current array, so D3, let's go D4, right, D1, yeah, D2 and D5. Okay, hang on, right, D5. So the front of queue pointer, well, we say that's just 2 because of course you have this index. Right, then the end of queue pointer, well, that's just going to be 6. And of course, yeah, the number of items 5 they've got. So, I mean, honestly, yeah, I think this question is just super simple, right? Of course, just copying it down from here. And then just, yeah, obviously given the numbers of these. Right, then a module add to will add a value to the queue by manipulating the array and variables in part A. The queue implementation is circular. When pointers reach the end of the queue, they will wrap around to the beginning. Okay, before a value can be added to the queue, it's necessary to check the queue is not full. The algorithm to add a value to the queue is expressed in 6 steps, right? Complete the steps. Yeah, so let's just go up here and we'll just try and add some more. So if we add another element, I don't know, maybe let's say D7. Right, let's also add another one. And well, of course, what's going to happen is, right, then the end of queue pointer is then going to go to 7. Right, let's try, I don't know, like let's say D10. Of course, right, then it's going to go to 8. And of course, well, obviously, yeah, the number of items is therefore also going to be 7 at this point. Right now, if we try to add a new item, well, because the index is 8, right, that's the end of the queue. So of course, well, now what happens is the the end of queue pointer then has to wrap around back to 1. Let's say this will be say D11, right? This is where we'll put the next one. And of course, at this point now, the number of items is going to be 8. So if we now try to add a new element, well, we can see, right, the number of items is 8, right? Therefore, well, we know the queue is full. So I think, yeah, that's what we want to explain, right? So if num items something, right, then jump to step 6, and step 6 just stop. So I think here we just say what equals 8, because yeah, this is if it's full. Right, then we want to increment something. So yeah, I mean, I suppose, well, 1, we want to increment the number of items, right? We also want to increment the the end of queue pointer. So let's maybe read 3. Yeah, see if this gives us any hints. Right, so if something, then set end of queue to. So I think this is the one that's talking about, well, if the end of queue pointer is 8. So yeah, let's write that, right, if end of queue pointer, or well, yeah, end of queue. Right, if end of queue equals 8, well then, yeah, or, well, in fact, okay, right, let's go greater than 8, because yeah, if it's 8, right, then that's going to be fine. That's just in the last element. So right, if it's 8, well, then we set it back to 1. So I guess, yeah, number 2, then this should be increment end of queue. Right, then 4, well, increment, well, this is the num items. So yeah, just the number of items in the queue. Right, then 5, set the something at the index stored in something, right, to the something being added. So when I think, well, maybe this can be element, right, set the element, yeah, at the index stored in, yeah, end of queue pointer, right, to the value being added. I mean, I think that makes sense. So if we just write this, yeah, set the element right at the index stored in, well, end of queue pointer. Right, and then that's going to be what, to the data, right, or yeah, I don't know, maybe to the value being added. Yeah, okay, because okay, I mean, well, here they call it a value, so yeah, I'm just going to call it a value here. Right then, number 4, a procedure RandList will output a sequence of 25 random integers, where each integer is larger than the previous one, and write pseudocode for a procedure RandList. Right, so I've gone ahead and just opened this in the site. And if first then, well, let's just go procedure, and that's going to be RandList. Right, here we don't have any parameters. Right, let's think then, what local variables do we need? And if we're outputting a sequence of 25 random integers, I guess, well, one is going to be an index, because, I mean, for this, well, since we know how many elements we want, well then, yeah, okay, I mean, then we can just use a count controlled, right, or for loop. So, well, of course, for that, we're going to need an index. Right, and I think what we want to think is, well, how can we make sure that each element is, you know, larger than the last? Because, of course, I mean, well, we can't just use a random number. But what we can do is we can have something where if we have, let's say, the current element, and, well, again, let's not say the current element, or let's say the previous element, and we say the current element will be the previous element, right, plus a new random number. And I think also plus 1 as well. And then if we do that, that should mean that, well, each element is therefore going to be bigger than the last. So yeah, I mean, like, maybe this is going to be easier if I just like try and code it. So let's go, yeah, let's actually add something here. We can go maybe what, previous element. Yeah, I mean, let's say previous. Right, so let's go 4 then, right, this would be index. This is 1 to 25. And what we want to say, well, previous, this is going to be what, previous, and then plus, right, a new random number. So hang on, yeah, let me just set this to A level. So we see rand then, this is going to take an integer, and let's just say 10. Now, in this case, it says what, the upper bound exclusive for the random number. So if we have 10, well, this could actually, you know, generate 0, because, well, of course, yeah, we also have to right, convert that to an integer. Just by removing the decimals. So what I'm going to do, I'm just going to do a plus 1 here, because otherwise you could have a situation where, let's say, right, if this is 0, because, well, yeah, let's just say, you know, you can have like 0.999, right, and then, well, that's just going to, when we use int, right, that's basically just going to get rounded down to 0. And, well, of course, you know, because we always want it to be bigger, right, then if we just have the plus 1, yeah, of course, right, even if this is 0, right, I mean, it's still going to be bigger. Right, and then, okay, so well, now then we just want to output it. And, like, we could just initialize previous here, right, just to 0. Right, then if we go next index, and yeah, let's go end procedure. And then I think that should be fine, so let's just call it, right, just to test it. And yeah, I mean, that seems, yeah, okay, right, so I think that seems to be fine. Yeah, okay. Right, then it says, okay, well, so the procedure RandList is modified so that the random numbers are also written into a 1D array result. Right, a new module is written to confirm that the numbers in the array are in ascending order. This module contains an if statement that performs a comparison between elements. Right, so well, if result x plus 1 equals result x, so of course this is saying, well, yeah, does the next element equal the previous element, right, or result x, yeah, greater than result x plus 1. So what that's saying, well, if the current element is what, greater than the next element. Right, yeah, then sequence false. Right, and we want to write a simplified version of the conditional clause. So I think, well, what we can do, of course, I mean, we don't need an equals and a sort of greater than. You know, we can actually combine that into what a greater than equals. Yeah, so what greater than or equal to. So let's try and write this. We want to go if, and I think here then we want to say, well, if result x is greater than or equal to, you know, result x plus 1. Yeah, and I suppose, I mean, here we actually don't really need the brackets, to be honest. Right, so result, yeah, this is what index x. Right, and if this is greater than or equal to, and this will be result, and then what, index of x plus 1. Yeah, then, well, let's just write the then as well. Yeah, and then I mean, that should be okay. Like, maybe we also need sequence false, but I mean, I don't think they would need us to write this. And yeah, let's just have the end if as well. But I think for this one, when they say the conditional clause, yeah, I mean, all they really want us to do is write this. And yeah, probably have the if as well. Okay, right then it says a global 1D array of integers contains 4 elements which are assigned values as shown. Right, okay, so 4, 2, 3, 5. A procedure process manipulates the values in the array. Right, the the procedure is written in pseudocode as follows. So first we assign this argument start to index, right? Then we assign 0 to total. It says while total is less than 20, we then get the element at the at this index in the mix array. Right, we assign that to the value. Then we do the total, right, plus value. So just calculating the total. Then we say if the index is less than 4, right, then we get what the current element, right, plus the next element, and we assign that back to the current element. Right, else we get what the current element, right, plus element 1, right, so always the first element, and yeah, just assign that, back to the index. Right, then we do what value mod 4 plus 1, and that's going to be, the new index. Right, then finally at the end we do this multiplication and assign it to what element 1. Right, then we want to complete the trace table on the opposite page by dry running the procedure when it's called as follows. Right, so call process with an argument of 2. Okay, I've just split screen just so we can see side by side. Now, if we look first then, well, they haven't actually assigned anything to these arrays. So if we look here, well, it's going to be 4, 4, 2, 3, 5. So let's just write those in quickly. Right, then it says we're calling this with the, let's say the argument 2. And then, right, this 2 is then assigned to the index. So let's just write 2 there. Right, total is also initialized with the value 0. Right, then we say, well, while total less than 20, of course that's true, right, currently it's 0. Then what we do, we get the mix at this index. So the index is 2, right, therefore, yeah, mix 2 is this one. Right, then we assign this to the value. And since we're in a loop, well, let's start a new row. Right, then we say what total is, well, total plus value, so 2 plus 0, right, that's going to be 2. Right, I think the if statement, I mean, let's go for a new row. I don't know, I mean, sometimes they actually do use a new row for an if statement, usually they don't. For some reason in this mark scheme they do. So yeah, let's try and just sort of, follow that. Right, anyway, so yeah, index less than 4. And like as I said in the other video, like if I do get a response from Cambridge about when to actually start a new row in a trace table, basically I'll just write in the comment what they responded, because yeah, I'm also not sure. It seems every exam paper they use different rules. But let's see here, right? So if index is less than 4, yeah, that's true. What do? We get the current element, right, plus the next element. So 2 plus 3, that's going to be 5. Right, then we assign it to the current element. So yeah, let's go here, that's 5. Alright, then when we leave the for loop again, when we leave the if statement, let's also, start a new row. So we're doing, right, value mod 4 plus 1, so value is 2, right, so 2 mod 4 is going to be 2, plus 1, right, that's going to be 3, and yeah, let's just assign that to the index. Right, of course, we'll then loop again, yeah, total is 2, right, so 2 is less than 20. Right then, let's try and go through these a bit quicker. Right, so mix index, right, the index is 3, right, therefore, right, that's going to be 3. Let's put that in the value. Right, so total, 3 plus 2, that's going to be 5. Right, index is less than 4, yeah, that's true. So then we go, mix, so here, right, mix 3, right, plus, this one. Right, so here then we're just going to assign 8, right, into this mix 3. Right, then we do value mod 4, so the value is 3, right, 3 mod 4 is going to be 3 plus 1, right, that's going to be 4. Again, 5 is less than 20, so we continue. Right, so we get the mix of the current index, that's going to be 5, yeah, this one. Right, so that goes into value. Right, then we have, total, 5 plus 5, right, that's 10. Right, in this case, if index is less than 4, right, that's false, so here we're going to this else. So we get the index, right, that's 4, and then plus mix 1, so that's going to be 5, and then yeah, plus 4. Right, then that's going to go into this element 4. Right, so now the value is 5. So, well, 5 mod 4 is going to be 1, and then, yeah, 1 plus 1, well, of course, that's going to be 2. Right, so again, well, total was 10, yeah, that's still less than 20. Right, then we go mix. So, right, mix index 2, right, well, this is going to be this 5 now. Right, so again, well, 5 is going to go into value. Like, I guess here we don't really need to change it. But yeah, I think, well, I mean, let's write it just in case. Right, then we want to say total, so that's, well, total plus value, yeah, 5 plus 10, right, that's going to be 15. Right, in this case, yeah, index less than 4, yes. Right, then we go, what's this one, yeah, 5 plus 8, right, that's going to be 13. And yeah, let's assign that, we can assign it here to mix 2. Right, then we want to go, what's a value mod 4, again, that's 5 mod 4. So what 5 mod 4 is going to be 1, and then yeah, 1 plus 1, of course, right, still 2. Right, and in this case, well, 15 is less than 20, right, so to continue. Then we go, right, mix index. So index here, well, okay, right, so index is 13. Right, let's go 13, we can assign that to value. Right, then 13 plus 15, that's going to be 28. Right, then we have... yeah, okay, right, so we've done this one. Right, then we get here, so we say, right, the current one plus the next one. So what, 13 and then plus 8, right, that should be 21. Yeah, and then what, we just go index, and the index is going to be, what, 13 mod 4. So 13 mod 4 is also going to be 1, because of course, well, 12 divided by 4 is going to be, 0. Well, yeah, 12 mod 4 is going to be 0. Right, so again, okay, this is also going to be 2. But now in this case, when we get here, well, it's going to be, what, 28 less than 20. Of course, that's going to be false. So it's just going to exit. What we're going to do, what's going to be total, right, multiplied by the index. So, right, the index is 2, yeah, total is 28. And, right, mix 1, so what, that's going to be 56. Okay, now, right, for 6, it says a function TestNum will take a 6-digit string as a parameter. The function will test whether the string meets certain conditions and will return an integer value as follows. Right, so 1 is if the last 3 digits are the same but not 0. Right, so I guess, yeah, like 444 if we look at these. Right, the next one, the last 3 digits are 0. Right, then the first 3 and last 3 digits are the same. So I guess, right, yeah, obviously 410 is equal to 410. Right, the function will return the highest possible value for the given string. Right, if a string does not meet any of these conditions. Okay, right then, yeah, 0 is going to be returned. Okay, so let's try and create this function then. So this is function, it's going to be TestNum. Right, it says it takes a 6-digit string as a parameter. I mean, I don't know, let's just say like num, or we could say, yeah, maybe num string. Okay, right, string, and here then the return value is going to be an integer. So let's go returns integer. Now, what we can think is that, well, if, I mean, okay, basically, well, we want to return the highest value, right? Therefore, we can check these conditions first. So if we check this number 3 first, of course, if that's true, right, then we return 3. Of course, right, else if it's false, well, then we can check this number 2. Yeah, else if that's false, right, then we check number 1. Of course, yeah, else we just return 0. Yeah, okay, so, I mean, like, if we need to declare variables, I'll go and do that later, but I think at the moment, I mean, let's just try and write it. So to do the, well, okay, this number 3, the first 3 and last 3 digits are the same. So here then, well, we can just use left, and then we can use right. So let's go left, this will take num string, and yeah, I think I would have to, okay, there we go. Okay, right, num string. Right, then what we want to say is, well, the number of characters we want to get. So here we want to get the 3 leftmost characters. Right, then let's just check, well, does that equal to right of num string? And again, we're also getting the 3 rightmost characters. Right, so if it does, well, let's just go return 3. Then let's have an else, and in the else, let's have another if statement. Right, here we want to check if the last 3 digits are 0. So again, yeah, this is not too difficult. We can also just use right. Again, that's going to be num string 3, and right, in this case, well, let's check, right, 3 zeros like that. Right then, the next one, so we want to get if the last 3 digits are the same but not 0. Okay, I mean, so I guess this one, well, we can use like 3 different mids. So we can use mid to get the 4th character, the 5th character, the 6th character, and just check that all of them are the same, right? But that they shouldn't be 0. Yeah, so like, I mean, this is probably not the sort of cleanest way to do it, but like if we just want to do this simply, so again, well, let's go num string, right? Then let's start at character 4. Okay, then we'll just get 1, and well, that will get this 4th character here. Right, then we want to check, well, so I guess first we can check, right, this should be not equal to 0. And well, I mean, then we're just going to want and. So, yeah, right, let's go and like this. And then what we want to check that this should be equal, right, to, well, position 5 and position 6. Yeah, okay. Right, okay, well then we're going to need another and yeah, let's just copy this. So here what we want to check, okay, yes, this is num string 4, right, then we want to get, well, character 5, and then, so, okay, so here then we're checking what our character 4 and 5 equal, and then here we also want to check what our characters, yeah, 5 and 6 equal. Now, you might think, well, do we need to check 4 and 6? But the thing is, of course, well, if 4 and 5 are equal, right, yeah, and 5 and 6 are equal, well then, of course, you know, 4 must also be equal. Yeah, just, I don't know, is that like commutative property, I think they call it? Yeah, or maybe transitive, I'm not sure. Right, so here, well, let's make sure just to have the return 2 for this one. Right, and then here, well, let's just go return 1. And yeah, let's have another else, right, an end if. And then, of course, here we can just go return 0. Now, of course, well, we could have return 0 here, right, or we could just delete that. Yeah, or we could just have return 0 kind of at the end like that. Yeah, both of those are going to be equivalent. Right, I mean, now then, well, let's just try and test it with the examples that they give. So let's go output, right, this will be TestNum. And yeah, let's copy these, right, so 253, right, 444. Right, then the next one, right, 253, okay, right, 000. Then, right, let's try 410, 410. And hopefully what this should say 123. Yeah, okay, right, this seems to work. And then, I mean, well, let's try something completely random, just, you know, 1, 2, 3, 4, 5, 6. Then, yeah, this one should say 0. Yeah, okay, so I think this is fine. Okay, right, the next one, a structure chart shows the modular structure of a program. Right, so we've got module A, then we've got a loop, and right, I guess what, some parameter T1 going into sub Y1. Right, this SA, well, we can see SA, this is going to be by reference, and the reason we can tell this is by reference is because, well, we've got the double-headed arrow. So yeah, this means it's going to be updated directly, you know, inside the sub Y2. Then, of course, what's sub 9, that's got R and A as, yeah, well, I get RA, RB as, well, let's say, you know, parameters. Right, and then, of course, if we've got this one, right, the shaded in, that means it's going to be a boolean, right, it's going to be a flag. Right, so we want to explain the meaning of the curved arrow symbol which begins and ends at module A. Right, so what this means then is that, well, sub, you know, Y1, Y2, and 9, they're just going to get called repeatedly in a loop. So let's just say that, maybe let's say, right, module A. Right, okay, yeah, module A, yeah, I think, I mean, let's not have those brackets, we don't really need them. Right, let's say we'll repeatedly call. Right, we'll repeatedly call, let's say, what, the 3 submodules. Yeah, I mean, let's say what, the 3 modules. And then, I mean, like, here it's a bit annoying, but I do think they actually want you to list them, because I noticed this on paper 22. Like, if you just said, yeah, I think, well, they actually had an if statement in that one. Like, if you just said, well, it will choose one of the 3 modules, right, they wouldn't actually give you the mark. You actually literally had to write out the exact name. Right, so we'll repeatedly call the 3 modules, well, sub, yeah, Y1. Right, let's go, what, sub Y2. Yeah, and sub 9. Well, I mean, let's say, yeah, in a loop. Yeah, I mean, so, I don't know, like, for me, I think that seems okay. Like, I'm just trying to think if there's anything else we can write. I mean, I think here, if we say, yeah, well, loop or sort of repeatedly call, I mean, hopefully that's 1 mark. And then, yeah, mentioning the 3 names, and I guess also module A, right, hopefully that should be the 2nd mark. Okay, it says the structure chart shows that sub9 is a function. A boolean value is returned by sub9 for processing by module A. The original parameter RA is of type integer and RB is type string. A record type myType will be defined with 3 fields to store the values passed between the two modules. Right, and we want to write pseudocode to, well, let's say define the record myType. So a record, well, we just say type. Right, and then here, what the name is just, well, myType. And then, I mean, inside the record is quite easy. We just have declare statements. Right, so, well, same as declaring variables. Right, so let's go declare, and the first one, what that's going to be RA. So yeah, let's go right RA, right colon, and then just integer. Right, the next one, what declare RB, and that's going to be string. Right then, what's the final one? So yeah, well, the final one is some return value. Yeah, okay, I mean, so as for what we call this, I mean, I don't really know what we would call this. Let's just go, right, declare. Like, I don't know, maybe I was going to call it, like, I don't know, boolean, or yeah, like bool or something, like boolean value. And then what that's going to be of type boolean. Okay, right, yeah, two O's. Okay, and then, well, since we have type, right, just have make sure to have the end type at the end. Right, the design is modified and sub9 is changed to a procedure. The procedure will be called with a single parameter, right, of type myType, and write the pseudocode for header procedure sub9. Right, now here then we have to think, well, is this going to be by value or by reference? Now, of course, if we're doing by value, well, then what's going to happen is if, well, basically, right, a copy of this myType will be created, yeah, inside, well, okay, I mean, let's say inside the function. Or, okay, well, hang on, right, yeah, I guess in this case, inside the procedure. Right, so what we're saying, okay, a copy of myType will be created inside the procedure. And then whatever, yeah, okay, so let's say whatever changes we make will only occur, right, on this kind of, you know, local variable inside this procedure. These changes won't be updated, you know, on the original object. And the reason for that is because, well, I mean, basically you've got two distinct objects. And I think, I mean, in another video I did just kind of explain this a bit more. But, I mean, if we're using by value, well, let's say this is our original myType, let's just call it MT. And we can say, well, this is going to be in memory somewhere. Now, when we just call S9, and let's say what we have, I don't know, some parameter, let's call it X. But of course, this X will be of type, you know, myType. Now, when we actually do this, well, this will then create another copy of this in memory. So I don't know, let's call it like NT2 or something. And then, of course, when we do, let's say like NT dot, well, like dot RA, and equal, yeah, assign it, you know, 1, 2, 3. Well, of course, well, I mean, that's going to assign 1, 2, 3 to this one, right? But it's not going to assign 1, 2, 3 to this one. Whereas if we use by reference, well, by reference won't create a copy, right? By reference will just use the original. Right, therefore, of course, we're going to be directly updating the original. So let's try and write this. It's going to be procedure. Right, the name is what, sub9. Right, so let's go byref. Okay, right, yeah, F. Now, of course, well, the other one is going to be byval. So yeah, well, just by, then yeah, val. But the thing is, you know, byval is the default, so we don't actually have to write that. Yeah, I guess unless they kind of specifically tell us to. Right? I mean, yeah, since this is just the default. Okay, and then write a single parameter of myType. I mean, let's just call it, I don't know, yeah, I mean, let's call it MT. Right, and then the type, well, that's going to be myType. Yeah, okay, so I think this one should be fine. Question 8 says, a class of students are developing a program to send data between computers. Many computers are connected together to form a wired network, and serial ports are used to connect one computer to another. Right, each computer is assigned a unique 3-digit ID. It also has 3 ports, each identified by an integer value. And right, they're connected to between 1 and 3 other computers. Right, messages are sent between computers as strings of characters organized into fields as shown. Right, so stx, well, that's going to be a single character, right, well, ASCII value 2. Right, then destination ID, 3 numeric characters identifying the destination computer. Right, then the source ID, again, right, 3 numeric characters representing the source computer. Right, then data, so a variable length string containing the data being sent, right, minimum length is 1 character. And etx, right, a single ASCII character, right, so ASCII 3, right, marking the end of the message. Right, for example, the following message contains the data "Hello Jack" being sent from computer, right, 202 to 454. So we've got what stx, then we've just got, yeah, this string. Okay, and I don't know, I mean, maybe some people might get confused. I mean, of course, well, the real message doesn't actually have these quotes. Yeah, I'm not really sure why they did those quotes, to be honest. Right, so then each computer will run a copy of the same program. Each program will contain a global variable myID of type string, which contains the unique ID of the computer in which the program is running. Right, then the first 2 program modules are defined as follows. Right, get data, which has already been written. This will return the data field from a message that has been received. Right, then if no message is available, the module waits until one has been received. Right, and then, well, receive file. This will take a file name as a parameter of type string. It will then create a text file with the given file name, right, no checking required. So I guess, well, we don't have to check if it exists or not. Yeah, since in pseudocode, right, that's not possible. Yeah, they don't have a function for that. Right, then we want to write the data field returned by get data to the file. And we'll repeat this until the data field is, what, 4 asterisks. And, well, yeah, these are not going to be written to the file. And then we'll output a final message giving the total number of characters written to the file. Yeah, so for example, what the sort of count characters were written, right, to the file, and then what the file name. Okay, so let me just copy this. Yeah, I think I'll just copy probably just this part. Yeah, then what we just want to write pseudocode for receive file, and module get data has already been written and must be used. So of course, as always, well, you can click here, go to the exam questions, right, find this starter code where, well, get data has already been, implemented. Right, so let's go open in code editor and let's just maximize this. Okay, so yeah, well, first then let's just okay, yeah, don't remove the line numbers. Right, let's just comment out that. Right, so what this was receive file, and wait, is it a procedure? I think it doesn't tell us we have to return. Yeah, so I think this one must be a procedure because it's not telling us that we have to return anywhere. Right, so let's go procedure, and well, this will be receive file. Right, it's going to take a file name as a parameter, so let's go file name. Right, that will of course be a string. Right, then what do we want to do? So it will create a text file with the given file name. Okay, so yeah, I think here we don't actually need any local variables. Right, I mean, one we will need though is the the count, right? So let's go, I don't know, like, yeah, character count, or yeah, like char count. Right, that can be integer. Yeah, and then what I suppose we're also going to need, yeah, probably we would want a variable to store the, I guess, what the return result of get data. So let's go declare, although I think, yeah, okay, yeah, so this one we actually would need a variable, since we actually need to use this 2 times. Right, first we need to use it while checking that it's not equal to this. Then, of course, if it's not equal to this, right, then we need to, yeah, of course, then we just need to write it. So, I mean, I think this, well, let's call it data, and that's, of course, going to be type string. Right, so first then we just want to, create the file. So let's do that with open file. That's going to be the file name, and we're going to say for write. Yeah, that's, of course, the mode. Right, then I suppose what we want to do, well, we just want to get the current data. Now, I mean, we could actually do this in a repeat until loop. So, yeah, maybe I'll try and do it in a repeat until loop first. So I suppose here what we can do then, let's go what data. That's going to be we're going to call get data. And does this, okay, right, so yeah, this needs no parameters. Right, then what we can do, well, let's have an if statement, and we'll say, well, if data is not equal to the, I guess those 4 asterisks. And in fact, hang on, let me just initialize char count. Right, so if it's not equal to those asterisks, well, then what do we want to do? I suppose one thing, we just want to increment the char count. Well, okay, not increment, but just add to the char count. That's going to be the char count, what then plus the length of data, because yeah, that's going to be the number of characters we're writing. Right, then of course, well, we want to write this to a file. So yeah, let's go write file. That's okay. Hang on, right, that's going to be the file name, and what is going to be data. Right, that's the variable, right, or the data that we're writing. Yeah, I think then can we just end if? Is there anything else we need to do? So we create a text file, yeah. Writes the file name, yeah, get data, okay, repeats until this. Well, we're going to do that in a minute. Yeah, outputs a final message. Okay, alright, so yeah, I think what we can do then, well, let's go until. And we want to loop what until, and that's going to be data is equal, right, to the 4 asterisks. And then what, so if it is equal, well, yeah, of course we're here then, well, first let's just close the file, right, and then we just want to output. And the message, right, so first then we want the number of characters, so, and in fact, actually, right, let me just copy this, it's going to be easier. Right, so here, what this should be the length, and that's, okay, no, wait, not the length, right, it's just going to be the char count, yeah, we've got that already. Right, let's say characters were written to, and yeah, here, well, let's then just go the file name, right, and then yeah, let's just remove all of that. Right, so I think that should be correct, and let's just go end procedure. And yeah, okay, so right, let's just call this receive file. Let's call it like, I don't know, test.txt. And yeah, hopefully this will work. Yeah, okay, right, it says 40 characters were written to test.txt. And I guess if you count those, right, that's probably going to be 40 characters. Yeah, well, of course, right, for this one, I'm just generating some random strings here in this get data. Yeah, that's why it looks, just kind of random. Yeah, okay, but I think, yeah, that seems to be fine. Let's try one more time. Yeah, now it says 421, which, yeah, okay, that seems okay. Right, then it says the use of the string, okay, for asterisks, as explained in the module description for receive file, may cause a problem. Right, explain the problem and suggest a solution. So I guess what the problem, well, that can be, let's say if a line in the file is actually this contents. Wait, hang on. Okay, so yeah, let's try and write that. Let's say what if the if the line contents, right, exactly equal 4 asterisks. Okay, right, yeah, if the line contents, right, exactly equal. And well, yeah, let's just write these. Right, well then, yeah, then what's going to happen? Let's say then, what the I guess what the procedure. Okay, right, the procedure, yeah, will consider. Right, let's say it will consider that it's the end of the file, or yeah, that there's no more data. What do they call it here? Yeah, okay, well, I don't know, let's say it's the end of the input, right, the end of the data. Right, so let's say, yeah, then, right, then the procedure will consider, right, this to be the end of the data. Yeah, and well, let's say, yeah, hence, hence not all data will be received. Or yeah, okay, right, let's say, right, not all data will be written to the file. Right now, as for the solution, I suppose one you could say, well, you could use, let's say, like a non-printable character. Or you could use, well, even better, rather than one, right, you say a combination of non-printable characters to represent, the sort of end of a file. But well, I guess, yeah, the end of let's say, well, the end of the input, right, the end of the get data. But of course, the problem with that is, well, again, what happens if someone has their line, which is actually those exact characters you've said. So I think a better solution, let's say if you look at, for example, IP. So right, in an IP packet header, well, yeah, one is going to contain what the source IP address, let's call it S. All right, also the destination IP address, right? Let's say PN, right, the packet number. But it's also going to contain the length. Okay, so the length is just the number of bytes in this packet. Therefore, of course, well, the receiver will know, like, did it kind of correctly receive all of those bytes. So let's just say that maybe, let's say before sending the data, we can send a message. We can send a message. Let's say, informing the receiver how many characters they should receive. How many characters? Okay, all right. Let's say, informing the receiver, right, how many characters we will send them. We will send them. And what we can say, the receiver will only stop writing, once it's received all of those characters. What the receiver will, I guess will only stop calling get data. Okay, the receiver will only stop calling get data. Only stop calling get data. Once it has received this many characters. Get data. Once it has received this many characters. So hopefully that makes sense. Okay, then it says 2 new modules are defined which will allow 2 users to exchange messages. Right, transmit already written. This takes 2 parameters, a string representing a message, an integer representing a port number, and transmits the message using the given port. Right, then chat takes 2 parameters, a string representing a destination ID, also an integer representing a port number, and it will extract data from a received message using get data and output it. Right, then it will form a message using data input by the user and sends it using transmit. And it's going to repeat until either the output string or the sent string is by. So reminder, each program contains a global variable myID, which is the unique ID of the computer in which the program is running. And messages are sent in this format. We just want to write chat, and it says get data and transmit must be used. Hang on then. Right, let's just try and copy this again. Also I'm just going to comment out that receive file. Right, so again, this is also going to be a procedure. Chat is going to take 2 parameters, so let's say dest ID. That's going to be a string, and let's say, I guess let's just call it port. What do we want to declare? So, we need to extract data from the received message using get data. Right, so I think, let's probably have something, let's just call it data. Right, that's going to be string. Right, forms a message using data input by the user and sends it using transmit. It's going to repeat until the output string or the sent string is by. So I think what that's saying so first we're just going to get the message from them, right? Then we're going to send them a message, right? Then we're going to get another message from them, right? Then we're going to send them another message. So it's always kind of them, us, right? It's always that same pattern. Let's also maybe say message, or this is kind of maybe like our message. And again, I'm just going to have that, and then if I need more, I'll add them more, or kind of add them later. Again, I think let's just have a repeat until. And I think this time, of course, it's going to be if either of the messages are by. So what do we want to repeat first? Then we want to, we want to extract the data from a received message. So let's go data, and then that's going to be get data. So then, I think when it says extract data, this just means get the actual message. So if we actually go back to the format here, well then to get the message, what we want to basically get rid of the first 7 characters, because what STX is 1 character, destination ID that's 3, right, source ID that's 3. So here then we want to start on the 8th character, right, then we want to get all of the remaining characters, right, until this ETX. So to give an example, well, right, I'm just going to say, right, let's say this is like the STX. Right, then let's say we've got, I don't know, like 111, right, that's the destination, right, 222 is the sender. Let's say our message is what, like ABCD. And then, I don't know, let's say we have another sort of, or yeah, okay, let's use this one here as the kind of ETX. Now, what we're saying then, so we want to start here at character 8. And what we can actually do, well, we can use the length, because if we look, what this total string, right, that's going to be 7, okay, right, so I think the total thing is going to be 11. Therefore, I think our calculation can be what the length of the string, and then what minus 4. Okay, hang on, right, no, okay, yeah, not minus 4. Right, the length of the string minus 8. And the reason it's minus 8 is because, well, yeah, here is 7. And obviously, well, yeah, here is 1, so that's going to be 8 characters we don't want. And if we start at the 8th character, I think, yeah, this should get it. So yeah, I mean, well, let's do that, and then I'll probably just explain it again. Let's say maybe what their message. Yeah, I think that should be okay. Right, so here, well, let's go right their message, and right, this is going to be mid. This will be the data. Right, and then, so here we said, well, we want to start at character 8, because, well, character 8 will be, you know, the first character in their message. Right, then the number of characters we want to get, well, this will be length. So the length of data, right, then if we just go minus 8. Now, the reason it's going to be length of data minus 8 is because, again, if we look at this example, well, this is 11 characters. Now, so of course, well, the length of 11 minus 8, right, that's going to be 3. And of course, we're here, right, 3 characters, that's how many we want to extract. Likewise, if we go, right, A, B, C, D, E, again, well, this time the length will be 13. Right, so our 13 minus 8, that's going to give us 5. And of course, yeah, here, right, that's 5 characters that we want to extract. Right, so, well, then we just want to output their message. Right, then the next thing we want to do, we want to form a message using data input by the user and sends it using transmit. Okay, so, I mean, let's actually see, what does transmit take? So I think transmit is going to be a procedure, yeah. Right, it's going to take a message, and it's also going to take a port. So I suppose here then, well, this is going to be our message. And then, well, the port, right, that's just going to be this port parameter. Okay, right, so here then, of course, well, we just want to construct this our message. And I think let's also just have an output saying, you know, please enter your message. Yeah, and then maybe like enter response. I think that should be fine. Right, then let's go input. And I suppose here, I mean, we can just input this into our message. But of course, well, then what we're going to do, we're going to want to add more to this. So let's say our message, well, what this can become. First it said we want STX, and I think if you remember it said STX is going to be ASCII character 2. So we can say, right, CHR2, and yeah, that will of course well get the STX character. Right, then we want what the destination ID. Yeah, and I think that's what it says. Let's just confirm. Yeah, destination ID. Right, so the destination ID, that's going to be, well, yeah, okay, just this dest ID. And now, I mean, this is a string, okay, so we don't have to convert it. But if this was an integer, well, then we'd have to do what num to string in order to convert to a string. Because, well, if we look, right, this concatenation, right, this can only work on strings and characters. Yeah, I guess it can't really work on, you know, numbers, right, integers, reals. Right, then I think the next one is going to be my ID, because, well, my ID, well, that's the source ID. Right, then we want our message, so, I mean, well, this is what they've typed in. And then I think to end, what is going to be CHR3, right, that's the ETX. And yeah, let me just zoom out a bit. Right, I mean, yeah, then can we just call transmit? Yeah, okay, and then, well, we're going to repeat until either the output string or the string sent is by. Okay, so, alright, I think, okay, so rather than just going our message, because what we're going to want, I mean, we're going to want just the actual sort of text input they typed. Yeah, you know, we don't want all of this stuff, right, when we're checking in the until. So let's go maybe our message and, I don't know, I mean, you could go, what, like, yeah, full, like the full message or something. Yeah, I mean, I don't know, like it's probably not the best name. Right, so what we want to do then until, well, that's going to be, well, either until our message is equal to by, and if we look, right, this has to be a capital B, right, or, and then that's going to be, yeah, their message is equal to by. Yeah, not byte. Right, and then, yeah, I think just end procedure. So let's just test this. Right, okay, we'll go, yeah, call, right, chat, let's say, like, 123, I mean, yeah, what did I give my ID? Okay, right, so my ID is, yeah, 111. And I think, yeah, here they don't give any format of how they want it to be output. Right, then the port, I mean, I don't know, let's try, like, yeah, port 80, right, that's just HTTP. So let's just run this. Okay, right, so, yeah, they said P, let's enter response, well, let's say hello. Yeah, okay, right, sent on port 80, hello. Right, I guess they've then sent this, yeah, kind of random string. Let's try response, I know, like 123. Yeah, I mean, let's just say bye. And then, yeah, here it's going to stop. The last part, module get data returns the data field from a message that has been received. If no message is available, the module waits until one has been received. Explain the limitation of this on module chat from part C. Right, describe the, describe a modification to get data to address this limitation. Right, so I suppose what the limitation is that if they don't receive a message from the other person, then they're just going to be constantly waiting. Right, they have no way of sending a message, they have no way of quitting. So yeah, let's try and say that. Let's say, right, if, yeah, let's say, what if they're, I don't know, okay, right, let's say if the other person, yeah, if the other person doesn't send a message, right, I guess what, yeah, then we are waiting. Yeah, let's say what we have to wait. Well, let's say, yeah, there is, I don't know, like there's no way to quit. Okay, yeah, let's say, right, no way to leave the chat. Right, yeah, no way to leave the chat, right, or send them a message. Right, then I suppose a modification, well, I mean, yeah, okay, I mean, so here we can probably mention multiple because it doesn't just say one. So we can probably say, well, there should be an option to leave the chat, for example, if they type Q, right, maybe Q for quit. Yeah, let's say maybe add an option to leave the chat. Okay, well, alright, hang on. I mean, first of all, let's say, right, they can send a message without having to wait. Right, so yeah, okay, let's say allow the user, right, to send a message, yeah, even if the other person hasn't sent their message yet. Yeah, I know, or like, yeah, even if, yeah, okay, let's say that, right, even if the other user, yeah, hasn't replied. And I think, yeah, let's say also, right, maybe also an option could be added to leave the chat. Right, an option, yeah, could be added, right, to leave the chat. Although, to be honest, I guess they do really have this, right, because, of course, well, if they can send a message directly, well, you know, they can then just send the string by, and, of course, yeah, by would actually do this. But I think, yeah, let's just say this anyway, right? Also, right, yeah, add. Yeah, you can add an option. Okay, right, yeah, an. Right, also, an option could be added to, right, maybe allow the user, yeah, to leave the chat. And yeah, well, say that leave is going to be there. Alright, yeah, guys, so, well, that was the final question then. As always, hopefully this video is useful. Any questions, just ask in the comments, and see you again in the next video.